All right, let's get back to the Leetcode and welcome back to Everything is Swift. I think with this kind of loading, I'm pretty sure I'm going to meet with the hard problem. Okay, the Leetcode problem is a maximum profit from trading stock with a discount. So we're given integer n and representing the number of employees in company. Each employee is assigned an unique ID from 1 to n. Employee 1 is the CEO, of course. Unless you're Steve Jobs, you will begin the employee 0. We are given a 1-bit integer array. Okay, present and future, each of lunch n, where present of I represent the current price at which I employees can buy a stock today. For the future of index, represent the expected price at which index employee can sell the stock tomorrow. The company hierarchy is represented by a two-dimensional integer array hierarchy, where the hierarchy of index represent the U and V, means that employee of U is the direct boss of the employee V. That means the zero index in here is the manager of the V. Additionally, we have an integer budget representing the total fund available for investment. So we have one budget that can be used between the manager and employee based on the values given by the budget in here. However, we have a company discount policy, so that if the employee direct purchase the old stock, then the employee can buy their stock at half of the original price. So we need to floor for the employee if the manager purchased the stock with the original price. So we have to return the maximum profit that can be achieved without exceeding the given budget. Okay, so there's some notes in here. We can buy each stock at most once. So we can only buy the maximum one time for each stock. We cannot use any profit and from the future stock price to fund the additional investment and must buy only from the budget. Let's try to dry run that given estimate in here. Let's consider that we're given the two employees in here. The present price for the manager can buy. Maybe I will create that some keywords so that we could keep track of it. So how about the, all right, I need to convert the blue color for employee. So here's a manager and here's the employee price. Yep, that's a little bit unfair, but will be fair. Employee 1 buying the stock price 1 and earn the profits. So if the manager buy the price of M in here, not sure why it's so difficult to move. All right, let me just get around. Okay, just consider like M and E in here. So here is the manager. So we are talking about the manager at the moment. If the manager buy the stock price at the present is 1, so we have a budget 3, and then sell back in the future with a 4. If we do the some mathematics in here, like 4 minus 1, so the company earn the 3 as a profit. Since the manager buying the present price, so the employee can get with half of the discount price. So if we 50% of the 2 is 1, so that is why we got the 1 in here, and then we sell it back with the 3, so that is the profit of 2. So 3 plus 2 is 5. That is how we got output in here. Since we calculate the 2 price, so we purchase with the 1 for the manager and the purchase with the same 1 for the employee. That is a 1 plus 1 is 2. So that is within the budget, and then that's the maximum total profits we achieve is a 3 plus 2, which is 5. So let's think about the estimate 2. Okay, we also need to understand about what is happening in the hierarchy in here. So we have a 2 hierarchy given here, 1 and 2. So 1 mean the index 1, 2 mean the index 2, since that is a 1 index in here. So employee 1 is the CEO, So of course, CEO of the company is the index one. And then how about we check for the, okay, just make sure like this is the manager and then that will be the employee. Yeah. So if we move to the second assignment, we have 2 employees, and then the present price we could buy is 3 for the manager. So let's say the manager buy with the present price of 3 and then sell it back with a 5. And then the maximum profit we could get in here is 2 if the manager buy. Because 3 minus 5 minus 3 is 2. And then since the manager buy, we can get the employee stock with a discount price, which is a 50% discount. But one thing we need to keep in mind is even though the employee want to buy, so 3 plus 2 is 5, which is already exceeds the budget. So that is the reason why we're gonna buy. So let's consider like if only the manager buy, we get the profit with the 2 because 5 minus 3 is a 2. How about the only the employee is purchased, since we have a budget of 4, employee purchase with the full price with no discount because the manager is not buying the shares. So 4, and then if we deduct the 8 minus 4, so we get the budget is 4, then we get the profits of 4. So if only the employee purchase, we get the profit of 4. So in that case, the question here is we have to retain the maximum profit that we can achieve without exceeding the given budget. So in that case, I would choose only let the employee to buy and then take the profits and return as the output of 4. That is the reason how we could get the 4 in the assignment 2. So if we could go more further, we also have another option. What if both employee did buy? We could leave with the original budget of 4. Yeah, that is one of the thinking we can think of it. And for the assignment 3, we could happen the 3 case. Maybe I will move the manager and employee to the right side since we are on the assignment 3. So we have a hierarchy of manager, let's say like 2 hierarchy. So manager is 1, 2 is employee, manager is 1, 3. That means our manager have a 2 employee under his hierarchy. So he's like line manager of the employee 2 and 3. So we have employee of 3 as a given, and the present price is 468, and we have a budget of 10. So let's consider like if we buy with a no discount, that's what we can think. But we will get the discount for sure. Have a discount policy if a company directly purchase their own stock. Okay, how about if no discount is it? So the employee purchase with the original price, which is 4. Let me write it down. Like we have a budget of 10 minus 4, which will begin the 6 remaining. And then we get sell it back with the 7. So purchase with the 4, sell it back with the 7. We got the profits of 3 because 7 minus 4 is 3. Okay, I will write down it here with a very ugly. Okay, that is a 3. Okay, how about we move to the second employee? So consider we don't have a discount, we buy purchase with the 6. So if we let the purchase with the 6 and then sell it back with the 9, so that will be also 3. So we are just trying to think it out loud for our thinking first. And then next is employee 3, purchase with the 8, then sell it back with the 11. That is also 3. Yep. And then that is for the no discount. So let's consider like we got the discount price. The employee is purchasing with the, so if we could think of it, so we are purchasing with the full price, that is not possible. Okay, how about we have a discount that is follow to the given question. So the manager purchase or original price with the 4 and then sell it back with the 7, that is a profit of 3. But next employee is buying with the discount price, which is going to be the 3. Maybe let me delete this. So 3. That is a very smart move. And then we can get like a profit as a 6. Right? And then if we do combine our total usage, so 4 plus 3 is a 7. And then how about the third employee? We are going to buy with the discount price, so which is a 4. So 11 minus 4 is going to be 7. Where is the 7 I could copy? Okay, that is a very good option. And then if we calculate that, it's a 4 plus 4 is 8. 8 plus 3 would become the 11, which is over the budget. So let's think about what are the possible options. We will only let the employee do to buy with the discount, right? So let's calculate it. We are not allowed that employee to buy in. That means we are not going to discriminate that employee. Is we are trying to maximize our profits. Maybe we can share back him with the salary. That is the joke aside. Okay, let's consider like we only buying for the first employee, which is the manager, with the full price and the sell it back. So that is the profits of 3. And then since we only were allowed the employee do with the discount. So let's consider the employee 2 is purchasing with the discount price. So with the combination of manager and then second employee, that is the profits of 9. But what about we let the manager and the third employee, which is the 3 employee, 3 mean like not the 3, it means 3 index employee purchase, and then we don't let the second employee to purchase. So that will maximize our profit. So if these two combined is only the 9, but if this first employee, which is the manager, and then that employee, which is the third employee, purchase, the profit total combined will be the 10. So we could think of it as a let the manager and the third employee purchase the stock. So which would receive the 10 as output. So that is how we receive the output of 10 in here. Yep, and then yeah, that's pretty much of it. And if we calculate it, that we are spending like 4 plus 4, which is the end of the budget of 10. So that is still the valid option. Right, that is pretty much for example 3. And then we still can think of what is the possibility. What if we bind the employee, second employee like 6 and 8? So that is already over the budget, even though if we purchase for the second employee only. So 6 minus 9 is only 3. So we have decided to bind the manager and the third employee only. Alright, pretty much explanation for the example 3, and let's try to go to the example 4. So same for the example 4, we got the 3 employee, 5, 2, and 3. But we need to keep the check. Not 5, 2, and 3. Sorry, my bad. So we have a 3 employee. The stock we can buy with the present price of 5, 2, and 3. The profits will be 8, 5, and 6. For the hierarchy, this one is quite different from the example 3. So 1 is the manager of 2, so that is straightforward. And then 2 is the manager of 3. So that means you have a manager, and then your manager also have another manager. So that is like your grand manager. Maybe that is a bad name. And then we have a budget of 7. So we can think of it like the previous approach, but the hierarchy is different. So maybe let's try to compute the possibility. Since we have okay, okay, that is a good thing to draw another manager. Let's go like GM. You can think it's a general manager or grand manager or grandmother. Alright, just joking aside. Alright, you have one who is a GM, grand manager, and then manager. Alright, that is a very terrible name. Let's go like SM. Ooh, not the Scrum Master. That's a senior manager. I really hate to bring that word as SM as a Scrum Master. Alright, we have a senior manager, and employee. Alright, what about our senior manager purchase the stock with the full goals, which is a 5, and then our budget is a 7. So 7 minus 5, where cost left as a 2, and then we will sell that with an 8. So we got the profit like a 8 minus 5, like a previous time, will be 3. So we got the 3 in here, and then next step is since the employee 3, we have received the discount price. So discount price of 2 will be 1. Okay, let's write the right 1 in here, and then we sell it with a 5. That is a very good profit, and then our total profits will be the 4. So 4 plus 3 is we have a total of 7 as a profit, but still we need to think for the employee 3. Okay, there will come like a little bit confusion, but since the employee 3, we only left the budget for 1 in here, since we have buying the stock as a 5 with original price, and then the second stock as a discount price, like 50% discount, we only left with the 1. But keep in mind that we are taking the floor for the discount price. Our remaining is a 3. So 3 divided by 2 is a 1.5. 50% of the 3 is a 1.5, but we are taking the floor that is going to be the 1. So we are allowed to buy that price with the 1, and then we are selling back with the 6. So 6 minus 1 will be 5. And then 5 plus 4 is 9. 9 plus 3 is 12. That is how we receive the 12 in here. And then if we could calculate it, everything is still under the budget, like 5 plus 1 plus 1, that is under the budget of 7. Yeah, that is pretty much done for the explanation, and that will be the very longest explanation in my life. And then I am pretty sure that is dynamic programming, of course. Alright, okay, what I could think of is I will create a default search. Before we start writing for the default search, let's create the things called like we need to flatten our hierarchy, because that is one base index, which will be a little bit difficult for us to tackle in the whole problem. Maybe let's call like a, I don't know, like group array of repeating integer. Okay, integer, and then we have a count of employee. So I just want to create the group of each array, and then I am going to create the adjacency list. Okay, how about let's call like employee. That is a terrible name. Let's call EMP. I just name E because we will have like employee and manager in our loop. And then we have a hierarchy in here. And then what we are thinking is, let's just write the manager, and then that will be the E of 0 minus 1, since that is a 1 base index. So detect the 1 will be become the 0. So the same for the employee will be the employee of 1 minus 1. So that will become the 0. And then what I'm going to do is I'm gonna use the manager as a key. Not a key, it's a manager index. That means like how many employee in that. Okay, let's think of it as this approach. We have a one, so we will use the manager as an index, and then that will be the sub. Okay, if it is I'm just create the nested array like this. Since we have a two sub array in here, so I'm creating like this. And then how I'm going to access is if index is 0, because we just detect the 1 from here. So if index is 0, we have a 2 employee, 2 and 3 in this array. So that is what I'm doing here. Alright, manager, and we am going to append the employee. Okay, maybe I will print out the result to see how it's work for you. Just return the 0 in here. So I will show the asymmetry. So we are expecting the 1 and 2. So since we have a 3 employee, I just create the 3 integer array, and then in the index 0, the reason why it's become into 0 is I just make the 1 base index to become the 0 index, and then we can easily access the who was the employee in that department. That is what I'm doing for this. Next step is just create depth search, since it is a dynamic programming approach, and then I may return the integer at first. So what I will think of it as okay, we need to assess the cost. Let's call like cost will be the, we have a present in here. So present me here, present of, actually I should name as an index, but if I name it as an index, that would be very weird. Maybe just put the youth at the moment. And then next is a discount cost, D cost. I should call as a discount. I was thinking what is a great naming for that. Alright, just name as a discount cost. That will be the present of u divided by 2. So that is a discount price. If our manager purchases the stock price, we as an employee will receive as a discount price. And then I'm gonna need the dynamic programming array. Let's call like just to keep the maximum profits of budget I, where the employee of parent did not buy. I mean, like, we don't have a discount. Let's call like max profit using budget I. I just want to utilize without having a discount for the first employee, and then that would be the same as nested array of 0 originally, and then count will be the budget plus 1. Since we're given the budget in like here like 3, so that will be creating like 4 index, not the 4 index, array size of 4 with the initial values of 0. And then the second one I will need is also the same, but this time is okay, parent did not buy. Second one is parent did buy. I should not be the parent because there is no parent name in here. I should call it as a manager. That would be the manager also. Okay, so if the manager buying, we will get for the discount for sure. And then what I was thinking in here, what to do next? That's the first time I was solving the problem. I'm really out of idea. Okay, maybe we will go through for the employee. Let's call it a V. Okay, the derivative of V is coming from here because we want to pass the U in here. So that is the original naming, because I don't want to name as an employee. That way, very terrible to trace back in the near future. So let's call like we have a group of U, which is our manager. And then what I'm going to do is, instead of return, I need like a size and then 3. Okay, let's return the tuple in here. I will be detupling for the each method. Let's call like child 0, because if we call it by the DFS again and again, that will be the child of the DFS. So child 1, and then let's call like V site. That will be the DFS of V, which is our each employee inside our manager department. Let's call department because that will make more sense for us. And then we're gonna need like a cost. Okay, let's call that one variable just to calculate the size of the employee. Let's call it cost. So that is the cost is coming from here. And then I'm gonna update the cost in here by using the same value, like doubling the size. So that was a little bit weird. And what I was thinking is, how about we revise from the budget inside the let's call like okay, don't use the index, just use I for the better brush. I'm going to make a reverse from budgeting of through the 0. So from budget, which is originally 3, by -1. So that will be going through like something like this: 3, 2, 1, and 0. So I'm making the reverse iteration loop in here. What I was thinking is, we can calculate the size in here already. Like, how about the mass of the sub array will be the minimum of our wait, that should not be the, that should be the V side. Okay, sorry, my bad. So doubling the size using the new values from our DFS, and then our V size and index. So we are comparing like what is the last index across these two items. And then I think I'm gonna need the 2 more array. Yeah. Okay, let's call it as sub profit 0, and then repeating the 0 and then with the same as the budget. So that is technically we are calculating the profits. What if let's say we have 3 employees in here. So what if the manager and the second employee buy? What if the second employee and third employee only buy? That is the sub profits of the 0. So for the thing is, sub profit is it's related to this one, our first DP. I will call like sub profit using the budget. Since manager did buy, we don't get the discount. So that is for the sub profit. The same for the second one. I'm gonna call it the sub profits of 1. Copy this, and then here will be the sub profits of using the budget I. So if the manager buy, we all got the profit. Like have about the discount price. Okay, we can use that sub profits in here. So what I was thinking is, I will go through like using the nested array, like for sub in 0 to the maximum of sub. So what is the maximum sub array we could get? Let's call like our candidate 0. The reason why I'm calling the candidate 0, that could be the manager, that could be the employee, that could be the least employee in our hierarchy. And then I'm gonna check like sub profit of 0, and maybe like detect from the index using the sub. So we are going through like the, alright, if I have to narrow down, I am doing this portion in here, like small tiny portion, like calculation the profit in here. So that is exactly what I am doing. And then after that, we will append with the chain 0 of SEP. Wait, let me think about it. Is that the correct approach? Yeah, this should be the array. My bad. So initially I was thinking like using the tuple, but at the end we are just sending the list of the employee through the whole DFS recursive call. So yeah, okay. Then it could change my whole thinking process. Let's consider our candidate of the profit is greater than our sub profit of index. What are we going to do? We are going to replace the sub profit of 0 with the index by using the candidate 0. So it will be the same for the candidate 1. Let's call it if candidate 1 profit is better than the, okay, we need to create the candidate 1 first. Sub profit of 1, profit of 1, that would be index minus sub, and then child 1 of sub. If our candidate 1 profit is better than the sub profit of 1 index, so I'm going to update the sub profit of 1 with the index and then candidate 1. Yep, that's pretty much done for updating our sub profits. So after everything done for the sub profit, we still need to measure our budget. So we just need to measure that is our within budget or not. So let me think, what is the best approach? I just do the for loop again for the budget, but I have no idea how to do the performance units in here. That is a very terrible approach. I can think of it for now. So what I'm going to do is I will calculate the index of each budget in here we are receiving for the manager didn't buy. So what I'm going to do is we're going to update with the sub profits of 0 with the index. The same for the 1, update with the 1. So after updating this, I'm starting to calculate the possibility of the cost. Let's say our index is greater than or equal to our discount cost. So discount cost mean here we have calculated in here. If more than the discount cost, that means we really cannot afford it. So we have to, how to say? So if the budget is within the range, we can do the discount with the sub profit of 1 will be the index minus discount cost. So the discount cost in here is just a value. So we are removing our discount cost from the budgeting, and then we are directly calculate the profit, which is the future of you in here, which is our employee, and then by deducting the discount cost. And then if our buying discount is greater than to our discount price, which is a DP1 of index, so or not index, should be the I. So I'm going to update the DP1 of index with the buying discount. I think that would be the same for the normal cost. So I think I can just copy paste it. Copy and paste. And let's call this the cost. So that is not the discount anymore because we are buying full. If you're buying the full, mean like we are using the sub profit of 1 also, and then that will be a full cost in here, and then the future of u minus cost, that will not the discount cost, that will be the cost, and then we have a bind full, and then dp of 0 because we are buying the full in here, because our dynamic programming 0 is for the without the discount, that means like manager didn't buy. And then if the bind full, what are we going to do is, wait, something wrong, should be the bind discount rightly. I should not be like this. That will be the, okay, that will be the bind full. Wait, what is wrong with my casa? Bind full for the dp of 0. Yeah, I think that's pretty much done. I can simply just return the dp0, dp1, and use site, which is a site we have calculated in here. So for the cost, say I can just call like our DFS of start from the 0 dot 0, which is the double of the budget, will be our reset. I'm not sure I will screw up the code base or not. That is the, okay, exactly in the line number 63 I screw up something. What did I do wrong? We are missing the comma in here. Wait, I have fulfilled all the comma. In the, oh my god, in the budget. Yeah, alright, let's try. Oh, also in here for sure. Alright, let's try. Oh my god, even. Oh my god, they're asking the menu for me to submit the answer. Alright, let's directly submit it. Not sure I will pass all the. What did I do wrong? In the line number 28, there is something wrong. So we are going the reversal of the Swift for loop from budget true or exactly. There's no extra t in here. Okay, let's try to run again. I don't know why I make a lot of typo in here. From I in stripe from budget. That's also correct. What did I do wrong? The root 0 by, not sure what is wrong. The unary operator cannot separate from it operand, but I have done correctly. Okay. Alright, that is a most messy code. Alright, this is solved. Not sure what is the time and space complexity, to be honest. And it's round. But it's passed in here. Maybe because of I did something wrong in here. Maybe let me double check what did I do wrong in here. So originally it is just flattened the array to the hierarchy by deducting the manager like 0 minus 1. That is no clue. So for the DFX, we are calculating the bots like cost, original cost, and then it is the present, and then discount cost is a half price of the discount. And then we have a budget in here, set profits also in here. Okay, so that is a real problem solving and debugging on real time. But I'm really not sure what did I do wrong here. From I through stripe, we are checking the middleman from 0 to maximum of sub array, if candidate of 0 is sub profits of 0, that's also true. We pledge to the child 0 or sub profits of 0. I think I messed up something wrong, but I cannot find it. Alright, let's try through. That was weird. It should be parts. Okay, for what I can think of is not also true. So let's calculate the discount price. We are checking the sub profits in here. The discount, and we detect the future of u minus cost. I don't use the discount cost in here also. And then we check from the one. That also true. I replace with the cost. The buy full, the profits, no idea. Yeah, that's exactly what I want to do according to my plan. And then, okay, let's try submit again. Maybe something screw up, or maybe I make a mistake. Sure, the Leetcode. Okay, that. Not sure our Leetcode problem AI can help me solve. Let's. Oh my, come on. What is wrong with my solution? Let's ask. Not sure I am allowed to use agent mode or not. That's the first time using the Leetcode AI agent. It's really useless. That is it. I would never. Oh man, that is terribly useless. Never mind. Alright, that is a very good case of AI will never take over the algorithm job. Okay, we need to check what did I do wrong. But it is passed locally. Why? Let me try to submit again. Yeah, okay. Okay, that is something terribly wrong for sure. Okay, let me skim through with my original idea of solution. Okay, I think the most case is under the DFS, since we are passing through it, and then I am iteration for the sub profits of 0 and 1, which is the budget plus 1. That's also exactly the what we want to do. And then I have a u size, and then u size plus equal to v size, and then child 0, child 1, and v size. Now I just passed the v in here, which is the g of u. So I'm gonna iteration through like v site and I. So okay, here we go, like sub profits of 0, I minus sub plus child of 0, sub, and if a candidate's in here, and now we got chat like a sub profits of 0 index is greater than, I'm gonna update the sub profits of 0 with the candidate 0. The same for the candidate 1. I have one doubt for that, but okay, let's move on. So I think that's pretty much fine. I think only one thing wrong with the budgeting in here. So if we come to the budgeting here, oh, my bad. That should be the original price, because since we are using the manager did buy, what should we do is we should use the approach with the manager didn't buy. Okay, let's try. How can I miss that approach? All right, that saved my day totally. Let me check. What is the time complexity for that? And what I can think of is that the time complexity will be the, I don't know, O of n into budget square, according to what I saw before when I trying to ask their Leetcode AI, but totally not useful without that. So for the space complexity, that will be the O of budget, because we are iteration from not to the O of n to the O to the budget. Yeah, that's a little bit weird. Yeah, that's pretty much for it. And then thank you for solving the problem together with me, and see you in the next video. Bye.